4 for now. Equals int short long double.
So we have our declared variables, and just keep in mind that when you declare, the type goes to the left of the identifier, and then if you're strictly declaring, no value is going to be given like we would in initialization.
Bool. Nine, 35. Okay, come back to that.
Of the way things are meant.
We don't use ChatGPT or Chat Alternative.
These people need to be back.
PG1.
Like again, they need to be back getting carrots out of the ground.
Except for understanding, like,
you know, deciding which potatoes are the good
definitions.
potatoes. This is real. This should never happen. This has gone on way too far.
Keywords and definitions are the new potatoes for.
I just passed away. So that's me for the day. I'll go back to bed.
If we as a society are already this dependent on ChatGPT and can't be bothered to Google something the moment the servers
it's going to get better for sure, right?
go down, we as a society are baked, and not in the fun way. Cookbooks, Google, I think even the flour bag has a recipe on it, or just call your...
Yeah, I was about to say, like, doesn't it have, like, if you're making carrot cake, doesn't it just say on the back of the cake what to do? Because, like, if I buy a cake mix, it just says on the back of the mix, put this much water in and then put it in the fucking oven. Like, it's not like this is complicated. Like, you don't need ChatGPT. They already ChatGPT'd it for you. Fucking...
Okay, let's go back to 35.
Strictly declaring, no value is going to be given like we would in.
Oh wait, did they die? Oh, it started. Oh! Shit. I died. Anyways, 35, let's see. My short, long.
Okay. And then we actually have assignment. So note that when you assign a variable, A, it has to be declared, like we do above. And B, we do not re-provide the type to the left, because it's just the identifier equals and then a value.
Initializing. We'll come back to that. We gotta speed run these lectures. We gotta like speed it up, speed it up. We need to get to 5 fast. Of course.
And then initialization, where we have an example of all the native types being declared and assigned a value at the same line. We have initialization.
Operators.
So we have the operators we've seen so far, which is assignment, and then your typical arithmetic, with the plus also being concatenation, and the percent.
We'll come back to that. Concatenation is another one we need to start talking about. Nice. Sweat harder, daddy. Sweat harder.
Mod, and then stuff you've seen us do already, with the insertion and extracting when we're talking about like CI or CN, and then scope resolution that we've seen a couple times so far, usually with like string with the standard library scope resolution, or CI or CN again.
Concat. Examples.
Where's string? So right here, we're jumping to concatenate two string literals, and it is giving me an error on the second string, and I'm trying to figure out why. I'm making on this one. So suggestion from online is insertion, typically only going to be used for.
Okay, we come back to that. We make no progress there. Oh my god. So it's like that, dude.
See out, at least for this. So, choose a Google to figure out C++ concatenation, because this 100% should work, or I'm just not seeing something that's very obvious. That works for a suggestion from online. Make it string variables instead of string literals. And then right there, a mix between a single literal and a variable.
Hey.
Do you have any questions on the operators, firing, initializing, assigning, anything like that before going? Okay, so when we're talking about casting, we're taking one type, casting it to another type, we're trying to transform it to another type. So we're going to say,
C car. Cast.
Alright, so right here, we have a car called cast int. We have it set to capital A. Then we have an int that contains cast car, and we're setting it to the value that's being cast. So we know it's being cast via the parentheses, and then the type that we're casting to, and then the variable that we're casting the value of. And then we'll be able to actually see the output at the very bottom. So before we continue, we're going to rebuild, and then we're going to rerun and look at the output. So starting at the top, we have the cout for welcome to day 3. Scrolling down, we have the concatenation example where we can see the hello world twice, one with the variables, one with a variable and a string literal. And then at the very bottom, we have the old value of A and the new value of 65. So the cast int as the value of A, we cast it on this line right here, which I'm going to put a note of. And then we can see, again, the capital A for cast int and the 65 for contains cast call right here. We can also do it in reverse, so do int cast to car, and we'll have it be 73. And then just notice my mistake up there. And put something in there as to why that worked. So the mistake I just caught was this was originally car, when cast int was a car originally. But the reason it worked is the containing variable, the endpoint effectively, was an int, so we were implicitly casting to an int. So two different ways to get the job.
Jesus Christ. I don't know what the fuck my team is ever doing.
I've done. This is more easier to understand once I flip it back to the proper type, simply because we see the intent of what's supposed to be there. We understand that it is going to end up being an int and not a car. So doing reversing, int cast a car, and then car contains cast int equals car, and then cast to car.
Cast to car.
And now we can rebuild it and watch it work backwards, or watch it get an error except for semicolon. So rebuild again. And then we can see the old value of cast a car being 73, and the new cast value being a capital I. So the other part of that is hard converting with like string to int, string to double, string to long, etc. Right here we declare a string variable and give a string value that can be converted. This line right here we've seen in a live demo and lab 2, specifically the standard library string to int. And then an example of a method call that we've seen prior is string to int, and then basically note out basically the string to int method and then the arguments, whatever we set it in. This is a method we have called before. Do we have any questions on any of the review material before we go on to the day 3 section? Right, so day 3 is all about methods. You can write a method within a method, but it is not best practice. It will create errors occasionally, and it will be a big headache. So putting that in notes. So you can create, like I said, you create a method within a method. Sometimes it will not error out, but most of the time it will.
Create methods outside of int main.
Cause headaches, so make sure you're writing methods outside of the main or any other scope.
this game. We'll take a break from studying. We're almost at an hour. Now we're done for lecture 3. We should be way ahead of this, but we still have like 2 weeks left, basically. I need more time. I can't. couldn't hear him. Thanks for wasting my time.
Unless you're purposely writing it for a class. And what I mean by that is if we scroll all the way up, in this demo project and like any other fresh console app that you make for C++, you're going to see the main method. So int main. And then we can also see at the very bottom the scope braces, or the scope brace for closing, and if we go back up, the scope brace for opening. We do not want our methods to be contained or declared inside of the main. We want them to be outside of the main. So methods can go here. If we were working in any other language, methods could also go down here. But not in C++. There's a thing called hoisting in other languages that when you get to it, and you can actually like write methods below the main. What hoisting does is it takes everything outside of scope for our project, so in this case for the main. Anything that's not written inside the main is the compiler throws it at the very top in no particular order. But in C++, we have to manually put everything at the top. So that's methods, like ideas about methods. So actually writing a method, we're going to start with the sum method that we saw on the slides. We may be getting rid of the public keyword here in a minute. I'm going to finish writing it out though. So I think the public errored out there because it was not in scope, so like using it for a class or anything like that, which we'll see later on. But right here, we have our first method, static int sum, with 2 parameters, and the goal is to return the sum of the 2 parameters. Also, you saw me type out this very wordy comment, basically defining the signature or the head of the method, so the static, the int, the identifier. And then the parameter list, and then the goal. So when we come back down to our method section inside the main, so again, note we wrote that outside of the main, we're now going to call sum. Now, if I go to run this, we're not going to see anything about that method. I didn't tell it to output anything, I didn't tell it to store the value. When you have a return, like we do with sum, generally the goal is to do something with that return value. If you don't have something capturing and storing that return value, after that method is called, that data point gets destroyed essentially. So right here, the for that would become of this method is basically lost because we're not doing anything with it. Now if we want to actually store it, we can set up a variable that shares a type of the return type, and it will actually store the returned value, and we can do something with it. The first thing that we're going to do is we're going to output. So scrolling up, the method declaration is outside of the main. Scope beginning here for the main, and then the scope of the sum method is outside. Now when we call it, we're actually inside the main, and we're right here. So now after rebuilding and running it, we'll see the last line of it running say store return and then the value 4.
Function.
And I forgot to put in an L somewhere,
Method.
so you can see it right there. And then on the old value, cast car new value is where I did not put the new line. So if you're following along, go ahead and throw the end L right there. We're going to rebuild and rerun so you can see it a little bit cleaner. Right there. Next, we're going to overload it like we saw in the slides. So we're going to scroll all the way back up to the top outside of the main, and we're going to create a new method, static int sum again. In this case, we're going to add in a third parameter. Okay, not sure why I got that weird list of errors, but continuing on.
So
So that list of 20 errors is back. I just finished writing the method. We're going to rebuild it, and it's still going to freak out on me. So, I'm going to look at the errors real quick and then go over everything.
Overloading some methods.
Some languages, the reason for the errors was lack of semicolon. I'm going to have to double check this because I don't remember putting semicolons at the end of methods for C++. However, it did make the errors go away, so we're going to treat it as if it is good for now, but I'm going to make a note of that, otherwise I will forget. So we have our initial sum method, static int sum with two parameters, number 1 and number 2, and then we have our overloaded sum with 3 int parameters, int number 1 and number 2 with 3. Also, you're seeing two different versions of basically how to solve the method itself. So in our first one, I have return number 1 plus number 2. Because it's a formula or an equation, it's going to break down, it's going to like process that and then give us the sum or the result, and that result is going to be placed on that line effectively, so it's going to return whatever that number happens to be. This is the shorthand way of doing it. Now, for the easy to understand, what I recommend people do, especially if you're a beginner programmer, is declare what we call a placeholder variable. Make sure it shares the type of method. We then alter the value of the placeholder variable. In this case, adding the 3 parameters together, and storing the sum inside that placeholder, and then return placeholder. The reason for this is so we can see everything happening, quote unquote, effectively, and it is, at least in my opinion, easier to understand when you're looking at it all like being broken down like that, opposed to just a single return rate. Question from online is, would you only add the placeholder to the overload? No. So we could do the same thing up here. So we have both methods like so. The reason for a placeholder variable is so you can understand how things are breaking down. What do you mean by can't just declare it?
Okay, so that's page 2 done, so now we're on page 3, hour 1, minute 5. Okay, we come back to that. We're almost done with lecture 3, so we're going to